Mentorship Awards from IBM and Microsoft in 2011 and 2012, and Best Spark Awards from NPTEL SWAYAM in 2019. Best Mentor Internship Award from Internshala AICTE in 2019. Best International Scientific Research Award from Research India Foundation in 2022. Sir has also represented India on global academic platforms across Malaysia, Thailand, Singapore, and Liberia. We are honored to have him with us today to share his expertise and insights. Without any further delay, I warmly welcome Dr. Asadi Srinivasulu sir to begin the session and share his valuable knowledge with us. I thank our FDP coordinator, Dr. RMD Shafi sir, for giving me this opportunity. Thank you, one and all.
Thank you, madam, for a nice introduction. Safi sir, are you recording the session, sir? Is there any?
Yes, sir. We are recording the session.
Yes. Yeah. Thank you, sir. Thank you once again. A warm welcome to 5-day faculty development program on today's my topic is deep learning and advanced architectures. Let me justify my title. Deep learning extension of machine learning. Machine learning extension is a deep learning concept. Machine learning is a part in artificial intelligence. Let me justify what is artificial intelligence. Artificial intelligence is a intelligent behavior in a machine, maybe humanoid robot. There are so many intelligent robots like Asimo and Sophia recently. Sophia took the citizenship of Saudi Arabia. And there are many large language models working as intelligent behavior. And we have chatbots like Alexa, Siri, Google Talk, etc. These are the examples of artificial intelligence. Science and engineering to develop intelligent kind of based applications by using statistical AI, machine and deep learning techniques. So, according to John McCarthy in the year 1969, he coined the term called artificial intelligence. From artificial intelligence is a big umbrella or paradigm. Under that, we have machine learning. Learning from the observational data with the help of three approaches like supervised learning, unsupervised learning, and reinforcement learning. We are solving the problems according to the complexity. And three approaches we are using like classification, clustering, association, rule mining, outlier detection, etc. The extension of machine learning is deep learning. Deep learning is nothing but learning from the observational data with a deep manner by increasing number of input layers and the number of hidden layers and various fine-tuning parameters we are using, dropout function. So that is called deep learning. Today I would like to explain advanced deep learning architectures like CNN, RNN, LSTM, and GAN. So CNN stands for convolutional neural network, RNN stands for recurrent neural networks, and long short-term memory LSTM, and generative adversarial networks called GAN. These are the four architectures I would like to explain with the practicals today. Keep in mind. So can you see the deep architecture, advanced deep learning and advanced architectures? Can you see my image? Left side and right side I kept two deep neural networks, artificial neural networks. It look like building. So next forthcoming workshop is AI driven data analytics from insights to smarter decisions. It is worldwide. We are organizing from Australia. And if anybody interested, please contact me. You can search my name in Google. You will get my email ID and phone number. And in YouTube also, you can type my name. There also, you can find my contact details. So this is the registration for November 3rd and 4th, 2 days practical sessions. 10 case studies I am going to handle with practical. And this is my background. Madam read that information 3 years back, old data. My profile changed last 2 years. Now I am working as a visiting professor at the University of Newcastle, Australia. And my one PhD from JNTU Anantapur with specialization data science, and one more PhD from my Indian Institute of Information Technology with specialization artificial intelligence. My supervisor is Professor Anupam Agrawal, and these are my research interests: artificial intelligence, machine and deep learning, data science, cyber security, health data analytics. Right now, I am handling with Australian groundwater data analytics. It's a project. Soil data analytics, PFAS data analytics I am doing. And over 200 publications of so far my career, and 40 of Science Citation Index, and 40 are from Web of Science and Scopus, and the remaining are listed in UGC care list. My publications you can find in IEEE Explore and Web of Science, Scopus, Science Citation Index. And I have a YouTube channel. Nearly 500 videos I have created all over the world with different subjects, different IT technologies. I'm a corporate trainer. Last 5 years, I'm handling many batches from USA, Canada, UK, Australia. Nearly 15 batches I have completed. And uh, and I'm a corporate trainer on generative AI applications using machine and deep learning techniques. And this is the core syllabus of generative AI with the 13 core subjects and followed by the 4 case studies. And I'm also corporate trainer on cyber security applications using machine and deep learning techniques. This is the syllabus of cyber security syllabus, like introduction to cyber security, Python programming in order to solve computer networks, cloud computing, information security, network security, and followed by the various real-time applications. And I'm a corporate trainer on data science applications using AI, ML, and DL techniques. These are the 13 subjects with followed by the 4 case studies. So within 60 seconds, what is happening in this world? Why I am dealing with a large volume of data? How large language models like ChatGPT, DeepSeek, GenAI, and Gemini, various large language models are generating a huge volume of data from various databases. Within 60 seconds, how many users are connected to this internet world? I would like to see the statistics of this within 60 seconds. In YouTube, 6,94,000 video hours viewed within 60 seconds. Facebook account, 11,035 fake accounts removed. 10.4 m viewing minutes are watched in the Instagram. Likewise, where the data is coming from, how many servers are required to store a huge volume of data. We are using a cloud computing concept. The backbone for cloud computing is data center and virtualization. Without internet, you cannot perform any kind of service-based application. What is internet? Internet is a network of networks. Internet is developed by Bold, Bernard, Newman. 3 scientists has been proposed. Network of networks means network is an interconnection between the computers in the fashion of local area network, wide area network, and metropolitan area network. And WWW stands for World Wide Web. It is developed by Tim Berners-Lee. Email is developed by Ray Tomlinson. And the backbone for cloud computing is a pay and use technology, data center and uh, virtualization. What is data center? Data center is a collection of high integrated servers at one place is called data center. And just like a football court, very height buildings, and virtualize each company having their own data center. Virtualization is the ability to perform our multiple tasks in a single system with the help of a hypervisor, Zen, Virtual Iron, and VMware, etc. So that is a backbone for internet and cloud computing. If you see the statistics where we are getting a huge volume of data, why I am explaining? In order to solve complex data applications, we are using deep learning. There is a connection between the explanation right now, what I am doing with the practicals. Can you see the number of users are connected to right now in the worldwide? Can you read this number, my dear friends? Anyone? It's very big. You can't imagine this number also. See here, very huge number. And see the how the statistics of each country. India plays the number one, China, USA, Indonesia, Pakistan, Nigeria, Brazil, Bangladesh, Russia, Ethiopia. See the graph, how the number of users are increasing automatically, number of participants are increasing. See? So this is the way we are getting a huge volume of data. That's why we require a cloud computing concept. The backbone for cloud computing is data center and virtualization. So same thing I have incorporated in this internet livestats.com, where we are getting a huge volume of data from servers like banking sector, stock market analysis, traffic data analysis, weather forecasting, health data analytics. See here, how many internet users in the world connected, total number of websites opened, emails sent today, Google searches today, blog post written today, etc. So same thing I have incorporated in this slide. Number of users are increasing automatically. The size of the data center also increases. So that's why we are using the measuring the data in computer servers and data center. Uh, Various data centers each company they are using, like in WhatsApp they are having their own data center at USA, Google having their own data center at USA. So that's why now we are using a traditional computer servers and systems. Now forthcoming already the boom is going to use quantum computing. Qubits we are using instead of traditional bits, like if you press capital A in the system cannot understand capital A. Internally it converts into ASCII format. ASCII stands for American Standard Code for Information Interchange. 108 keys are presented in the keyboard, each key having its own ASCII value. That's why if you take enter having ASCII value is 10. If you divided by 2, binary equivalent number is 1010. Same way, if you press capital A, system cannot understand. Capital A value is ASCII value is 65. If you divided by 2, we are getting binary equivalent number is 10001. That's why computers understands only binary language. Binary language is nothing but ones and zeros. 1 bit is 0 or 1, 4 bits 1 nibble, 8 bits is 1 byte, 4 bytes is equal to 1 word, 4 words equal to 1024 bytes, 1024 bytes is 1 kilobyte. After that, megabytes, gigabytes, terabytes, petabytes, hexabytes, octabytes. Hi, I am Robo, my speed is 1 terabytes and memory is 1 zettabyte. So there is 1024 ZB is equal to 1 yottabyte. Again, I searched in the internet, is there any new terminology measuring the data? Yes, there are two more terminologies presented. 1024 YB is equal to yottabyte is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. 1024 geobytes is 1 infinity. Same thing we are representing in a mathematical range. Kilobyte is 10 power 3. Megabyte is 10 power 6. Gigabyte is 10 power 9. Terabyte is 10 power 12. Petabyte is 10 power 15, hexabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 24, brontobyte is 10 power 27, geobyte is 10 power 30. This is the way we are measuring the data. This is the syllabus of data science. This is the introduction to data science, 10 major concepts. Then followed in order to solve any complex applications of big data, AI, machine and deep learning applications by using Python, we are solving real-time applications. Up to 11 topics is a core Python programming. The 12th topic is standard library, that is advanced Python programming. So it starts with variables, basic mathematical operations, and so on, collections likewise. In advanced Python programming, we are using libraries, are also called as packages, are also called as application programming interfaces, APIs. NumPy is a numerical Python, SciPy for scientific Python for solving all scientific applications, Pandas for data manipulation purpose, scikit-learn for machine learning, matplotlib for visualization, sklearn for big data and machine learning, Theano for artificial intelligence, TensorFlow for big data and machine learning, Keras for machine and deep learning, and PyTorch for machine learning applications purpose. We are using these packages. So widely used top 10 standard libraries in Python: NumPy, Pandas, Matplotlib, Request, SciPy, Scikit-learn, TensorFlow, Keras, Beautiful Soup for HTML and extensible markup language documents, Flask, Django. These are the microweb frameworks for Python programming. So Python for everything, irrespective of the computer science domain, we can solve by using the related libraries. Madam, any doubt? Somebody is asking any doubt? So this is the syllabus of statistics. This is the core concepts of data structures and algorithms, database management system, warehousing, artificial intelligence, generative AI top 10 concepts, data mining major concepts, then natural language processing, big data technologies, artificial neural networks, machine learning, deep learning. So deep learning is nothing but learning from the observational data with a deep manner by increasing number of input layers and a number of hidden layers and a number of activation functions like ReLU and softmax. So many activation functions and dropout functions, fine tuning parameters we are using. These are the top 10 latest deep learning concepts. Deep learning foundations like mathematics and concepts, optimization and training strategies, regularization and generalization, convolutional neural networks in vision, means audio, video, text, graphics, animation kinds of applications, recurrent models and sequence learning models like recurrent neural networks, long short-term memory, and we have graphics recurrent unit. You can call it as a very CPU, GPU extension, attention mechanism and transformers, self-supervised and representation learning, transfer learning, fine-tuning and parameter efficient tuning, generative models like autoencoders, variational autoencoders, generative adversarial networks, diffusion models, evaluation, explainability, and responsible deployment machine learning operations. Today, I would like to demonstrate four advanced architectures like CNN, RNN, LSTM, and GAN, generative adversarial networks. And the 13th module is augmented reality, virtual reality, in order to solve any real-time audio, video, text, graphics, and animation kinds of applications we are using. So these are the major projects under my research laboratory. So far, we have solved 153 projects so far. So the last one is prediction and detection of soil properties, groundwater, using machine and deep learning techniques. So one more interesting application of deep learning, very interesting question. Might be I have explained last time also. Again, I'm coming with another program. If I'm asking when is your date of birth, immediately saying, sir, my date of birth is 15th July 1978. Okay. So if I'm asking the question, when is your death date? Seriously, you are feeling what is this stupid question, sir? You are asking death date. Yes, there is a solution. Still, R&D is ongoing for death date. Finding the approximate how many years we are going to live based on our constraints like habitual activities and the way you are taking diet, exercises, and so many input parameters like biological data, date of birth, height, weight, lifestyle factors, genes, etc. And there is a model called life to vector. Model is nothing but a simplified version of the reality, and it integrates AI models by using machine and deep learning advanced architecture models integrated like CNN, RNN, LSTM, generative adversarial networks integrated, and leveraging these technologies to develop the lifespan of a human being. See the final output we are finding how many years I can live. So based on my input characters, input parameters I have given, and there is a program called Write a Python program to simulate and visualize personalized lifespan prediction by using biological data and lifestyle habits and genetic traits using rule-based scoring method and displaying the results with a comparative bar chart. If you see the program, we are using importing life to vector. That is a model. Matplotlib for visualization purpose, NumPy for numerical calculation, and we are defining function to predict the lifespan based on input parameters, placeholder for prediction logic, and a random lifespan prediction. And input data we are taking biological data, date of birth, height, weight, lifestyle, and a prediction, predict lifespan and plot the prediction graph. So let me execute that program CMD. So I think everybody knows Python programming, how to execute. Very simple. If you don't know Python also, you just go to Google and type Python software. You will get a Windows version. It takes only 2 minutes. Once installed Python Windows version, you can type like this Python. So it shows the what is the latest version you are using, 3.13.7. Python can be executed in two ways. One is IDLE and another one is a scripting way. Python is developed by Guido van Rossum from Netherlands. While playing the circus game, he got an idea, why don't I can avoid the drawbacks of C and C++. I can invent a new language called Python. There is a snake game is ongoing in the circus. He suddenly kept that name. So Python can be executed in uh, two two ways. This is ideally very simple. So integration, development, learning environment. Okay. So if I write anything, immediately you can see the result. C is equal to A plus B. And you can see the output of C, 3 plus 4, 7. What is the A value? 3. What is the B value? 4. And what is the C value? See the 7. So I don't want this one because I want to execute my own programs. That's why I can use a scripting way. So I'm writing program, notepad space, wet. So one simple program like write a Python program to find the death date of a human being by using input parameters, by using deep learning techniques in order to solve this sort of complex application program. See here, write a Python program to perform death date of a person. So I'm using NumPy, Matplotlib, same whatever I have explained, the same program. Input parameters like biodata, gender, blood pressure, cholesterol, and exercise hours, diet, smoking, alcohol, and everything. So now I'm executing Python space. But now see, so we are finding the death date of a lifespan factor. Can you see? See now? See here? 77 years. Average lifespan is 70 and predicted lifespan is 77. So this is one of the application. See here, no problem. So many applications you can see. Yeah. So this is the application program I have executed. Same program, bar chart, and I have changed parameters and the lifespan. Same program with various feature importance in lifespan like risk score like alcohol consumption, smoking history, like body mass index, age, etc. I have a channel. If you type my name in Google or YouTube, you will find nearly 500 videos are uploaded. It is not for money, but whoever my scholars and my students, they can view that videos on latest technologies. If you have time, 1 minute, you can type my name, Dr. Asadi Srinivasulu, ASADI, and space SRINIVASULU. Please subscribe and forward to your communities, your friends, students, etc. Okay. Now, welcome to any doubt so far. Just introduction I have given, small introduction. Now we are moving to our concept today's deep learning and advanced architectures. These are the top 10 concepts I'm going to explain with the practical demonstration. Fundamentals of neural networks, how this deep learning evolved, and what is neuron, and what is artificial neural networks, that is called ANN. It is a base subject for machine and deep learning techniques, and then followed by the advanced technique of ANN is CNN for image processing. Then recurrent neural networks and long short-term memory for audio, video, text, graphics, animation kinds of applications. How we are using transformers and attention mechanisms for solving any health data analytics on chest X-ray images, CT scan images, etc. Autoencoders and generative adversarial networks for face recognition applications. Deep reinforcement learning for gaming applications we are using. And the advanced concept of artificial intelligence is explainable AI. It is represented as XAI for deep learning transparency. Federated learning, we are running our application in different data centers, and I'm using their environment for executing our own application. And privacy preserving AI. Optimization techniques for deep learning models. Deploying deep learning models in production by using machine learning operations and cloud artificial intelligence. Okay. What is the technical name of this image? Can anyone? My dear friends, by seeing this image, what are you thinking now? Soumya ma'am, what is your answer for this image? Any idea?
It is look like as a waveform.
Oh, it
Sir,
is waveform. Fantastic. But we are dealing today deep learning concept. Can you correlate? The answer should be related to deep learning advanced architectures. You might be knowing CNN, RNN, LSTM, generative adversarial networks. I kept for both purpose, funny purpose and subject purpose. You like it, this image? Yeah. So see the technical name of this image is deep neural network architecture, and the actual technical image I'm going to show you. This deep learning is a broader family of machine learning methods based on artificial neural networks, and it learning can be supervised, semi-supervised, unsupervised. You may be knowing supervised means there is a label, there is a target class. Based on that one, we are dividing the data. Semi-supervised, 50% of supervised, 50% of unsupervised. Unsupervised means there is no label, there is no target class, but I don't know what is the size of the data is presented, but I don't know how to classify the data. That's why we are using um, similarity measure concept here, clustering. So Manhattan distance, Minkowski distance, Euclidean distance we are using. There are 2 points like x1, x2, y1, y2. We are using Euclidean distance formula called as square root of x1 minus x2 whole square plus y1 minus y2 whole square. That is used for similarity measure by using Euclidean distance. So based on that similarity measure, we are calculating the distances between 2 points whose points are similar to the nature, making as a cluster. That is called clustering. By using C means clustering, K means clustering, fuzzy C means clustering, agglomerative clustering, density based clustering, etc. So deep learning gets its name from the fact that it involves going to use deep into several layers like input layers, hidden layers, fine tuning parameters, activation functions, which also includes hidden layer. So now tell me what is the technical name of for this image, sir? You tried very good last for last image. Now tell me the what is the technical name of this image? I have incorporated all sort of terminology, jargon of deep learning in this image. Everything is there. How many artificial neural networks techniques are there? CNN, RNN, LSTM, MLOps.
It's a look like as a human, how the human brain will work as a. Here we are depending on a machine learning as well as a deep learning, NLP. We have communication merging with the here.
Oh, very good, very good, very good answer, sir. But you are not reaching a final answer, technical answer. The way you are guessing is correct, but I'm expecting a pure technical answer for this image. Can anyone try? In chat box, can you write what is the technical name of this image? Whether it is JPG image, whether it is MPEG image, or TIFF image. What is your answer for this image by seeing all the neurons are connected to each other? Any answer? In chat box, somebody is typing. It's okay. Can I give answer for
It's like as a
technical?
brain, sir. It's like as a
Oh,
brain.
yeah, you are trying very good, sir. It looks like a brain, but it is not correct answer, sir.
We have some neuron connection with the brain, sir. Brain, sir. Based on that one,
Yes,
here we are a communication with the each and every technologies into the deep learning. I think
yes.
that's right.
Yeah, you are absolutely trying to reach the answer, but not correct the answer, sir. Okay, this is the answer. Deep learning word cloud. How you are going to publicize about your college, sir, Aditya? By using pamphlets, by using brochures and banners and dashboards and so many things you are using. This is one more way of publicizing about deep learning with word cloud. We are integrating with all sort of jargon of deep learning, terminology of deep learning. It's okay. What are the schools so far deep learning they are handling right now? Yeah, deep mind, deep deep mind. So they are using a reinforcement learning. Sir, unmute, sir, unmute. Sorry, mute, sir. And OpenAI, they are using transformers. That's why ChatGPT came into the large language models. Facebook, they are using self-supervised learning. Google, they have started AutoML. Apple, federated learning. Microsoft, machine teaching. Amazon, transfer learning. IBM, quantum machine learning. These are the schools of deep learning. So what is a deep learning? How it came from computer science. So in computer science came from in computer science you can see the artificial intelligence, the study of computation and computer technology, hardware and software. Machine learning is a part of computer science, algorithms that can make predictions through pattern recognition. So under machine learning, we have deep learning, a form of machine learning that uses a computing model inspired by the structure of the brain, which requires less human supervision. So brain of AI, you can call it as a deep learning algorithms, that is called neural networks. Just now one sir explained correct answer. Open source technology, large data sets, labeled data, engineering experts, specialized hardware, how it is going to play a vital role. Deep learning. So deep learning industries, see so many industries, use cases, you can say finance sector, healthcare, retail industry, media, manufacturing, agriculture, and insurance, recycling, etc. So what is deep learning? See here. Deep learning is nothing but learning from the observational data with a deep manner by increasing number of input layers and the number of hidden layers, activation function, fine tuning parameters, etc. If you see, the artificial intelligence is a big umbrella. Under that we have machine learning. So it is a subset of AI. Deep learning is a subset of machine learning. Deep learning uses neural networks to simulate human like decision making. That's why, see the differences between artificial intelligence, machine learning, deep learning when it came into the market. 1950s, engineering of making intelligent machines and programs. That came in the 1950s. John McCarthy coined the term called artificial intelligence. Then 1990s, 80s, the ability to learn without being explicitly programmed, machine learning came into the market. Then learning based on deep neural networks in the year 2010 onwards, 2017 till now we are using deep learning models. So that's why, that is what is the deep learning concepts. Same application, if you apply machine learning, you cannot find all the features. Whereas in deep learning, we can extract a feature extraction plus classification. We can find whether it is a car or not. We can find out what is the cost of the car. Also, we can find what is the model of the car. So everything, it is a deep learning is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. That's why deep learning models can recognize complex patterns in pictures, images, text, sound, and other data to produce accurate insights and prediction. And uh, so many features we are extracting. So deep learning is a section of machine learning methods that uses artificial neural networks with more than 3 layers, like conduct data analysis for automatically, like artificial intelligence layer, machine learning layer, and deep learning layer. Who invented deep learning? Alexei Ivanenko. He created small functional neural networks in the year 1960s. Then we are using deep learning for detecting objects, recognizing speech, translating languages, making decisions, etc. Wherever unstructured data, complex data, then deep learning will, we are remembering deep learning we can use to solve complex applications. So enabling missions to think like humans called artificial intelligence, training missions to get better at a task without explicitly programming called machine learning, using multi-layered networks for machine learning called deep learning. See the amount of data you are handling in x-axis, y-axis performance. So deep learning is far better than machine and older learning algorithms. That's why how data science techniques scale with amount of data. Why did deep learning? In order to solve very complex applications, and deep learning requires large training data sets. So this is the best example of deep learning. Can you see how there is a one scenario? Right side a bucket of water with the tap, and their left side we have environment. So there is an intelligent robot agent is there. If agent is moving right side, fire is there, it gets the punishment. There are 6 steps, like first observe the environment. The agent is observing environment, right side fire, left side full of bucket of water with the tap. Then select action using policy. If you perform any action, that agent gets punishment. It goes to the fire, it can burn, so minus 50 points. Then it comes to right side and take the water and pour on the fire. So if it moves bad move, then punishment. If it moves right side, good move. So next time it is next time it is taking right step to solve. So right side, see, left side we are having a bad step, and right side we are using a good step. By using deep learning techniques, and we are solving gaming applications by using this reinforcement learning techniques, like based on the punishment and reward, we are solving the applications. So the deep learning process, like understand the problem and whether deep learning is a good fit or not, identifies the relevant data sets and prepare them for analysis, choose the type of deep learning algorithm to use, and trains algorithm on 75% of test training, and you can use remaining 25% for testing. Then test the model's performance against unlabeled data. That is called a clustering. So deep learning model lifecycle, we are feeding as data and labels, structured data, unstructured data, reference models, create and update models, train test models, evaluate model. If accuracy is unsatisfactory, we are increasing the size of the data, and we are increasing the number of epochs so that we can increase the accuracy. Then a deep learning pipeline, we have a data and streaming. We have n number of tools we are using. Distributed data storage and streaming. We are using Hadoop distributed file system and Cassandra, Google storage, etc. For users, we are using data preparation analysis. We are using tools like Spark and Apache, Zeppelin, Jupyter Hub. For frameworks and cluster, we are using PyTorch, TensorFlow, etc., like deep learning tools and distributed hosting. Models like building machine learning models, model serving sending model to clients. So what are the machine and deep learning tools we are using? Machine learning programming languages, Python and R are very popular programming languages. Machine learning tools like TensorFlow, Scikit-learn, Veka, and deep learning tools like Keras, PyTorch, etc. Analytical tools like Spark and Hadoop. Visualization tools like Matplotlib, Seaborn, Jupyter, ggplot, etc. So what is the major difference between machine learning and deep learning? In machine learning, it can find out whether it is a car or not. Whereas in deep learning, we are extracting features plus classification. We can find what is the car type, car model, and when it make, and whether it is car or not, model number, cost, everything we can find out. That's why we are using deep learning models. So these are the factors comparison of deep and machine learning. So data requirement factor, it requires large volume of data for deep learning, whereas machine learning can train on lesser data. For accuracy, provides high accuracy in deep learning. Machine learning, it gives less accuracy. Training time takes longer to train because it handles large volume of data. So it takes less time to train because we are using small amount of data. Hardware dependency requires GPU, graphical processing unit, to train properly. Trains on CPU, central processing unit. Hyperparameter tuning we are using in various different ways in deep learning. Machine learning, limited tuning capabilities. So same thing in this one. And these are the terminology I have explained already. So pre-activation function, activation functions, back propagation, why it is used. Gradient descent is a first order iterative optimization algorithm for finding a local minimum of a differentiable function. So gradient descent is an optimization algorithm for finding a local minimum of a differentiable function. And see the x-axis weight and y-axis cost. So gradient descent is simply used in machine learning to find the values of functions parameters. Those are the coefficients that minimizes a cost function as far as possible. Then use cases of deep learning. It uses for knowledge discovery and predictive analytics. For example, Google uses deep learning to build powerful voice and image recognition algorithms. Netflix and Amazon use deep learning in their recommendation engines, and MIT researchers use deep learning for predictive analytics. See, there are many industries and use cases. These are the top 10 deep learning algorithms use cases. We are using a face unlock in smartphones, selfie filters, networking, cab booking, Hey Siri Google, personalized marketing, Gmail spam alert, online food delivery portals, Play Store recommendation, etc. Because deep learning is widely used in computer vision like audio, video, text, graphics, animation, natural language processing, autonomous vehicles, healthcare diagnosis, fraud detection, recommender engine, speech recognition system, robotics, climate modeling, and drug discovery. So this is the deep learning process. We have n number of input layers, x1, x2, x3, and so on. And we have weighted functions, bias, and fine tuning parameters, dropout function, and gradient boost, hidden layers, and finally we are getting output layers. So deep learning workflow, how it works, it involves data collection, pre-processing, model selection, training with large data sets using neural networks, optimization, evaluation, and deployment for real-world application. Okay, and this is the typical deep learning process. 1980s neural network, how look like input layer. Node is a see a computer or any neuron. Hidden layer, output layer. It links carry signals from one node to another node, boosting or damping them according to each links with weight. Whereas in deep learning neural network, modern, we are taking input as a image, input layer, identify light or dark pixel values, then identify edges, identify combination of edges, identify features, identify combinations of features by using multiple hidden layers, process hierarchical features. Finally, we are getting output is a George or not, identifying combinations of features. So we have three important learning algorithms like providing lift for classification and forecasting models. We are using deep neural networks. Feature extraction and classification images, we are using convolutional neural networks. Especially for image processing, we are using CNN. For COVID-19 virus prediction on chest X-ray images, CT scan images, etc. Which image is positive, which image is negative. For sequence of events, language models, time series, we are using recurrent neural networks. There are various top 10 deep learning algorithms are there. We have categorized into supervised and unsupervised. In supervised, we have convolutional neural networks, classical neural networks, recurrent neural networks, whereas unsupervised learning, self-organizing maps, Boltzmann machines, autoencoders. That's why what are the functionalities can perform by the DNN? DNN is for classification and prediction and time series prediction. CNN for prediction and time series prediction. And for computer recognition, vision for classification. RNN LSTM for all prediction and time series prediction, computer recognition and vision classification. So that's why deep learning methods can be classified into four types like CNN based methods, examples AlexNet, Clarify, SPP, VGG16, GoogleNet, ResNet, etc. RBM based methods like deep belief networks, deep Boltzmann machines, deep energy models, autoencoder based methods like sparse autoencoder, denoising autoencoder, contractive autoencoder. Sparse coding based methods we are using: sparse coding, Laplacian sparse coding, local coordinate coding, supervector coding, etc. So this is the function we are using: multiply rule, power rule, sum rule, difference rule, product rule, quotient rule. So all mathematical derivatives we are using in order to solve each functionality of the model. And there are four advanced architectures I am going to explain with the practical demonstration now. So convolutional neural network is a type of artificial neural network. It is used in image recognition and processing that is specifically designed to process pixel data. Recurrent neural networks are type of neural network where the output from the previous step is fed as input to the current step. RNNs are mainly used for sequence classification, sentiment classification, and video classification, etc. And long short-term memory is an artificial neural networks architecture used in the field of deep learning. Okay, LSTM networks are well suited for classifying, pre-processing, making predictions, series data, etc. Whereas a generative adversarial networks is a machine learning model in which two neural networks compete with each other to become more accurate in their predictions. So see here convolutional neural network pipeline, how this architecture works. See here, kernel input image. We are using convolution means combination of two or more functions. Then pooling means we are combining input and hidden layers, dropout function, activation function. Convolution, we are combining more or functions, pooling. Then we are using featured maps, featured maps, pooled feature maps, flattened layer like a dense layer. Then finally we are getting output like Donald, Goofy, Tweety, etc. Same recurrent neural networks. It illustrates how data flows through the input, hidden, and output layers with the feedback loops that allow the network to remember past information for sequential data processing. So long short-term memory here, see here how this network manages sequence of data over the time like T3, T2, T1, T plus 1, and vanishing where recording is less than 1, vanishing where recording greater than 1, exploding, and data over time by controlling vanishing and exploding gradients through gated recurrent connections. That's why it is called long short-term memory. Then a generative adversarial networks, we are taking real data and fake data. So which one is by using a discriminator, by using generator two functions, we are creating a real data with a discriminator for real image. By using generator, we are using input noise, latent space. Fake data we are creating with again discriminator, it generates fake. So best example for defaking image. You know defaking? Recently, Rashmika Mandana image, which one is original, which one is fake, we are unable to identify. The famous application of generative adversarial network is recently one of the Japan scientists. He invented one of the app from 1 year baby, 5 years baby, 10 years, 15, and so up to 60 years, how the baby is changing over the period. Such type of facial expressions, first year baby look like, 5 years babies, 10 years, 15, 20. Over the period, how it changes the facial expressions. Such type of application is developed by using generative adversarial networks, GANs, very popular technique. So now by using top 10 deep learning tools like TensorFlow for solving the any natural language processing applications, Microsoft Cognitive Toolkit for image and speech applications we are solving, Cafe for we are solving very big applications in machine learning applications. Chainer, it is for automatic differentiate APIs based on the machine learning framework. Keras for solving big data and CNN, RNN. Deep Learning 4J is a tool for using distributed deep learning framework. So these are the deep learning code libraries we are using: TensorFlow, PyTorch, Apache, MaxNet, etc. These are the tools, and these are the top 10 deep learning libraries: TensorFlow for deep learning, PyTorch for machine learning, Keras for deep learning, Theano for deep learning, MaxNet for scalable deep learning, Cafe for deep learning again, Fast API, Fast AI for deep learning library, Chainer. There are plenty of libraries. So out of all the libraries, we are using one big programming language called Python. So these are the applications of Python.
Hello, sir. Excuse me, sir.
Yeah, yeah, please ask any doubt.
Hello,
Yes, sir. I'm hearing your voice.
sir.
Please.
Excuse me, sir.
Yeah, yeah, please tell me.
Sir, if you don't mind, please go to previous slide, sir. I want to take a screenshot. If you don't mind,
Yeah, yeah, sure, sure. This
six,
one?
seven, eight, nine, 10. 6, 7, 8, 9, 10. Not this one, sir. Wait, sir. Please, sir. Done, sir. Okay, sir. Next slide, sir.
Okay.
This one.
So these are the applications. So instant visual translation, predicting the future, chatbots, medical care, self-driving cars, colorizing the images, read lip movements, photo descriptions, advertising, deep dreaming. These are the applications of deep learning. So many applications: autonomous vehicles, PolyB, RNN noise, Grammarly, Perlmutter, Meridian, Neurala Brain, Zero Eyes, WaveNet, Six Sense, Robbie AI. See, these are the fascinating applications of deep learning. Self-driving cars, detection of growth delays in children, automatic handwritten generation, pixel restoration, colorization of black and white images, deep dreaming, demographic prediction, sound addiction for silent films, news aggregation, automatic mission translation. So these are the top 20 applications. So just now I have shown this application. Most useful deep learning tools: TensorFlow, PyTorch, Keras, Hugging Face Transformers, JAX, ONNX, Open Neural Network Architecture, Apache MaxNet, Fast AI, Light GBM, Gradient Boost Method, Deep Speed. And these are the top 10 open source deep learning tools: Anomaly, Marine, Google Assistant, RSFMRI, CNN, LSTM. And these are the future directions and innovation in deep learning: self-supervised, unsupervised learning, neural architecture, transformer models, explainable AI, federated learning, privacy preserving AI, efficient and green AI for sustainable deep learning, multimodal deep learning, symbolic, adversarial robustness and security in deep learning, future, quantum deep learning and AI powered edge computing. So, introduction to future directions and innovation, key innovations in deep learning, emerging research trend, challenges and ethical consideration, future applications, case studies. So, now first application I am going to demonstrate: self-supervised and unsupervised learning. So, self-supervised learning is nothing but extracting useful representation from unlabeled data by predicting parts of data from other parts. By using unsupervised learning like clustering helps identify patterns without labels. So the first program, write a Python program to perform unsupervised learning using k-means clustering on a synthetic data set and visualize the clustered data using principal component analysis. So this program, now what is supervised learning? What is unsupervised learning? Supervised learning, we know the model, we know the data set, and we know the target class. Based on the target class, we are dividing into groups, classes. And unsupervised learning, we don't know the name of the data set, unlabeled data. and huge volume of data. And we are applying models like ANN, CNN, DNN, RNN, LSTM, GAN, etc. Finally, we are clustering the data. That is called unsupervised learning. Semi-supervised learning means 50% of supervised learning, 50% of unsupervised learning is nothing but a semi-supervised learning. And reinforcement learning means agent. Based on the punishment and reward, we are solving the problems, especially in gaming applications. So these are the self-supervised learning examples. So now I'm going to demonstrate a first application. See here, all of you, slide number 2549. See. So my first application, notepad space. So write a Python program to perform unsupervised learning using k-means clustering on a synthetic data set and visualize the clustering data using principal component analysis. So required libraries we are installing: NumPy, Pandas, Matplotlib, scikit-learn, and principal component analysis, creating a synthetic data set, creating a data frame, and applying k-means clustering, applying PCA for visualization, plotting the clusters, and finally we can see the results. Python space. See here. Now we are getting clusters by using a PCA, principal component analysis. So we are getting output of first program for today's class. It is taking little bit time because my system already running with now it is going to generate output of a first application program. Okay, let it be like this, it will generate. So this is the PCA component 1 and PCA component 2. And see, is there any still running? Yes. Now my screen is visible. Can anyone acknowledge me, please? My screen is visible.
Yes, sir. Yes,
Yes,
sir.
sir, visible, sir.
Sir, visible.
Yeah, thank you so much. For x-axis, we are seeing the principal component and see orthogonal components. Cluster 0, cluster 1, cluster 2. So green points 1 cluster, cluster 2, orange points cluster 1, and blue points cluster 0. So likewise, we are solving unsupervised learning application. Second application, neural architecture search, NAS, and automated AI model design. So here, what is NAS? Neural architecture search. So it automates the design of a deep learning architectures to find optimal structures. It reduces human effort and improves model performance. Write a Python program to automate a deep learning model design using neural architecture search with Keras tuner optimizing hyperparameters such as the number of layers, neurons, and learning rates to improve model performance for regression task. For this one, sir, how much time is there, sir, so that I can plan it? 15 minutes more.
Sir, we have 15 more minutes, sir.
Yes, sir. Yes, sir. I will finish it.
Last 5 minutes we can use for.
Yes, sir. Yes, sir. Within 10 minutes, I'm going to execute a few more programs.
Okay,
So,
okay.
Yeah,
Yes,
this is NAS, neural architecture search and automated AI model design. See here, individual requirement, maximum memory usage, maximum false alarm rate, minimum detection rate we are using. Finally, optimal design. So this is the second program, and transformer models and attention mechanism. So transformers process sequential data using self-attention mechanism, making them powerful for NLP and vision task. So this is a third program application, write a Python program to train a transformer-based NLP. So it will be, I'll execute this program. Let's see. Yeah, where is that? Yeah. Okay. So next program, Notepad space NR3. So write a Python program. See here, write a Python program to train a transformer-based NLP model that is distilled for text classification and visualize the self-attention mechanism to understand how the model focuses on different words in a sequence. So Python space NR3. It takes time. So meanwhile, I will execute, I will show you the output of the transformer models and attention mechanism, how these transformer models are working. This is the structure, and this is the output heat map I have generated. And fourth application, explainable AI for deep learning transparency. So it is extension of artificial intelligence is called explainable AI. It enhances the transparency in deep learning models by providing human understandable explanation for their decision. It helps build a trust and accountability by revealing model reasoning, reducing bias, and improving interpretability in critical applications like healthcare and finance. Write a Python program to train a convolutional neural network, that is CNN, and on MNIST dataset. It is a free repository available in GitHub and GitHub, Kaggle, and UCI repositories. And we are using shapely additive explanation to visualize the and interpret the model's prediction, enhancing transparency and explainability in deep learning. So we are installing required libraries. So this is called explainable AI architecture, and this is the output we are getting. We are recognizing 721. Yes, we are recognizing 721. Then fifth model is federated learning and privacy preserving AI. So federated learning enables AI models. It's a extension of AI to train on decentralized data across multiple devices while preserving using user privacy. It enhances data security by ensuring that sensitive information remains localized, making it ideal for application in healthcare, finance, and personalized API system. And the last application, efficient, and see, we have generated output. See, my screen is visible, sir. Notepad NR 3.5. So
Yes, sir, visible, sir.
1000 compressed data, and this is the third application. And now I am showing the sixth application, efficient and green AI for sustainable deep learning. AI models are being optimized to reduce computational cost and energy consumption, making them more sustainable. Techniques like model pruning, quantization, and energy efficient hardware contribute to reducing AI's environmental, etc. This is federated learning and privacy preserving AI, and multimodal deep learning, that is integrating of vision, language, and audio, video. Like multimodal means audio, video, text, graphics, animation kinds of applications. Okay, so the last application, write a Python program to demonstrate adversarial robustness in deep learning by training a CNN on the MNIST dataset, generating adversarial examples using the FGSM attack, evaluating the model's performance on these perturbed inputs, and visualizing the impact of adversarial attacks on model accuracy. Now see this program. I'm going to show you NR3. See, very simple. Command prompt CMD. CLS to clear the screen, notepad space, NR6. So this is the program. See here. Write a Python program to demonstrate adversarial robustness in deep learning by training a CNN on the MNIST dataset, generating adversarial examples using the FGSM attack, and evaluating the model's performance on these inputs, and visualizing the impact of adversarial attacks on model accuracy. Now see Python space. This is the last application for today's practical session, and we will see, we will take questions and few more concepts. Let me check. This will take a little bit time. I will check. This is the output original data and adversarial data. And yeah, this is one more program for visualizing future advancements of deep learning techniques. Okay, I will show you this one also. Practical demonstration. So these are applications. Okay, very fantastic applications. So with this one, the theory part I'm closing. These are the libraries of deep learning. These are the applications. See, fantastic applications. Because of time, I am moving very fast. Now see, now still it is running Python, this application. Okay, meanwhile, you can ask any doubts related to deep learning advanced architecture models. See, this is my channel, and these are my awards. Recently, I got it. From IGI Global Best Researcher Award, outstanding from USA, AI-driven healthcare research, and from Research India Foundation, I got Quality Research Award 2024, and 2025 from IGI Global from USA, August 4th, 2025, I got the Best Researcher Award from that publisher, AI-driven healthcare research, and a Lifetime Achievement Excellence Award from Research India Foundation. These are the latest one. And my daughter got a state first rank in 11th grade. She got 10 lakhs cash prize award from Narayana institutions. And these are my gate score, and this is my GRE score, 330 out of 340. This is my TOEFL score, 100 out of 120. And my gate rank is 1978. That's why I got admission in IIIT Allahabad. And I was school first in APRS. And this is next forthcoming workshop, AI-driven data analytics from insights to smarter decisions. This is your Aditya College today's workshop. And these are the programs I have acted as a resource person, Planet Care. And this is one of the Welfare Institute of Science and Technology Management. This is from Australia. This is from Australia. This is Research India Foundation. And there are many workshops, nearly 500 workshops I have conducted last 5 years during COVID onwards. And any doubt so far, please ask me doubts. Sir, Shafi sir, 10 minutes more.
Yes, sir.
Let them ask any doubts, sir.
Yes, sir. Yes, sir. Yes, sir. I request the participants. We have very good opportunity to interact with a person like Asadi Srinivasulu sir. Not only relating with the sessions today, even pertaining with your research progressions or your research areas. He was very prominent and nice enough to give you suggestions. You can have an interaction.
Yeah, thank you, sir. Anyone, please give your feedback, whether you like this lecture or not, and any comments from your side. How many participants are there, sir?
Sir, around 90 plus, sir. 90 plus.
Oh, good number, sir. Good number. My dear friends, see here our generative adversarial network is running. First approach means first iteration is completing right now. It takes one more step and 3 steps. Okay, meanwhile, you can ask any doubt related to machine learning, deep learning, artificial intelligence, any doubt related to research collaboration, writing proposals, writing book chapters, any journals related. I mean, see, if you are interested, if you need any PhD guidance related papers, publishing papers, and writing conferences, anything, I'm going to help you. You take my number from Shafi sir. Otherwise, you can type my name in Google and YouTube, Dr. Asadi Srinivasulu. You will get it, my number and my email ID also. Any
Sir,
feedback?
it seems Polaya sir is available.
Yeah. Hello.
Polaya
Dr.
sir.
Polay sir, please. Any doubt you can ask me, sir.
Oh, thank you, sir. Very good evening, sir. Good
Good
evening to
evening.
my.
What is your
Sir,
feedback
if you
on?
please switch on your video, sir. We want to see your face.
Yes, sir. Yes, sir. That is true, sir.
Thank you, sir. Thank you so much for your
Sir, and
encouragement. Really.
everybody can open your camera and you can take some screenshots, sir, for a document purpose also. Shafi, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Mine is not coming.
What is this? Yeah, this is the output. I got it. My dear friends, my screen is visible.
Yeah.
Sir, my screen
Yes.
is visible.
Yes,
Yes,
sir. Yes,
doc.
sir.
Yes, sir.
Yeah. See
Yes,
here,
sir.
adversarial networks. We have used on MNIST dataset approach 1 by 3, loss percentage 0.8, and approach means second iteration loss we got 0.19, and third iteration we got 0.12. So test accuracy on clean data 0.95, that means 95 percentage. Accuracy on first 500 clean samples we got 97.60, and accuracy on first 500 adversarial samples like epsilon. See, this is the output we got it. Okay. So likewise, there are a few more applications on deep learning. Because of time, if it is 2 hours, I could have executed a few more, 5 more applications are there. So this is clean and adversarial. Okay, thank you. Sir, Polai sir, please ask me doubt, sir. What is your doubt? Hello.
Yes, sir. Yes, sir. Really, I'm very thankful to my Guru Garu, Dr. Asadi Srinivasulu Garu, who is
Yeah.
my role model and inspirational today's speech. I've been really inspired and as well as enlightened my knowledge. Though I may be one of the good researcher so far, which I got been proven as a senior professor. Recently, I got my decision, my designation as a senior professor in one of the.
Congratulations, sir.
Thank you, sir. And coming to the point, though still I'm a learner because my
No problem, sir.
the,
Everybody, teacher is a learner. Teacher
Professor
is a learner.
Professor Asadi Srinivasulu sir is my guide, my mentor, and my role model. And
Thank
even
you.
the way he's lecturing, giving to everyone, maybe not just like enlightening, but fundamentally how so the previous scientists was like Einstein's, how they're preparing their scientific things like that. He was giving the lectures. Really, today also I'm blessed such a lecture. While he's giving such a lecture, even I remember that eminent personalities, scientists and professors who are proven in our India as well as in global wise. I'm going to see very soon Professor Asadi Srinivasulu sir, also one of the great scientific person and as well as great professor. So we need
Thank you for it.
Asadi Srinivasulu sir blessings forever to everyone to keep our person like him. So even I am suggesting my kids also be his kids. So how his kids are very blessed. That is what even my encouraging my kids also, my children's also I'm encouraging.
Very good.
Really very
Thank you.
thankful to you, sir. And I may be with you since 2000 onwards.
Yeah,
Uh,
correct.
Really 25 years connecting with yours and learning each and every element of information. It's a great blessings to us, sir.
So thank you for nice
With
feedback, Polai Garu. You
thank
ask
you so
your
much.
doubt. No need to praise and all these things.
No,
Okay.
sir. The doubts which you are given that itself cleared, sir. That's what.
Okay,
Really.
thank you.
And
And
thank
any
you.
other participants, please give a chance to others, sir.
Sir, a
Please.
request
thank
from
you.
the
Yeah, Doc.
participants. They are
Yeah,
expecting
Doc. Isaac
your
Frimpong
slides,
wants
sir.
to ask a
If you
question.
don't mind.
Yeah.
Frimpong wants
Any-
to ask a question.
Yeah, please. Hello. What is your
Yeah, Doc.
name?
Yeah, my name is Frimpong.
Oh, Frimpong. From which country?
Yeah, from China.
Oh, China. How come China? Your
Yeah.
accent is different from Africa, and right now you are in China.
Yes, I'm from Ghana, but now
Oh,
I'm a
Ghana.
student
Nice
in
to meet
China.
you.
Yeah.
Please ask me doubt. What is your
Yeah,
doubt?
sir. So, sir, because of the deep learning and then
Yes.
advanced architectures, there's no need for researchers to prepare a questionnaire
Why?
for information, because
Yeah.
I think that deep learning can do everything for you without preparing a questionnaire.
Yes, 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 yes. Thank you so much. But this is advanced concept. If you want to do any deep search in your application, finding minute level features, we are extracting